Hello everyone, so we are going to start now with the discussion of 23rd Jan JEE Main session, and that is also of shift 1, right? So we are going to discuss the physics portion over here. Now let's start with the first question what we have over here. So the first question over here is, there is a wire of uniform resistance lambda ohm per meter and it is bent into a circle of radius small r, and another piece of wire of length 2r. So this is the wire over here which is having 2r length, right? Now, there is a wire, another piece of wire of length 2r is connected between point A and B. As shown, the equivalent resistance between point A and B is. So first we need to find out the equivalent resistance for this. The lambda is given, that is the resistance per unit length is given. So if you multiply with 2r, you will get the resistance of this. Then you will have to find out the length of this also, which is going to be pi by 2 into r, and the length of this also, which is going to be 3 pi by 2 into r. Now all these connections, they are in parallel, okay, they are in parallel because you are connecting between A and B. You want the value of equivalent resistance between point A and B. So based on that, I think you will be able to find out the answer. The correct answer is going to be option number 3. Clear? Sorted? It's an easy question. Then there are two blocks with masses 100 gram and 200 gram, and they are attached to the ends of the spring A and B as shown in figure. The energy stored in A is E. The energy stored in B when spring constant Ka and Kb, if for A and B respectively satisfy the relation. Okay, so the spring constants have this relation 4Ka is equal to 3Kb. Now, obviously, what I can just assume over here is this spring is going to come into equilibrium, and when it will be in equilibrium, the mg force over here will be balancing the kx, right? So same is going to be the case over here. Now, when they're talking about the energy stored in A, they are obviously talking about the spring potential energy, right? So the spring potential energy, you will have to calculate half kx square based on whatever is the value of x. Similarly, you will have to calculate half kx square, whatever is the value of x, by equating with mg. And then k and kb relation is given. So based on that, you will have to equate between the energies also. The answer of this, using the same analysis, will turn out to be option number 2, which is 3, okay? Moving ahead, there are 4 persons which measure the length of a rod as 20 centimeter, 19.75, 17.01 and 18.25 centimeter. The relative error in the measurement of average length of the rod. See, how to calculate the relative error? First, you will have to calculate the L mean. And L mean will be equal to, you add all of them, L1 plus L2 plus L3 plus L4 whole divided by 4. Then you will have to calculate the delta L mean, which eventually is going to be the mod of delta L1, that means how much L1 is differing from the mean value, plus mod of delta L2, plus mod of delta L3, plus mod of delta L4, right, whole divided by 4. Now once you have calculated the mean absolute error and the mean value, then the ratio of delta L mean is to L mean will give you the value of the relative error, which is being asked in the question. Answer is going to be 0.06, okay. So understand the approach, calculation you can do. Now, this is an assertion reason problem. So here it is given, the assertion is, individual atoms in ferromagnetic material possess a magnetic dipole moment and interact with one another in such a way that they spontaneously align themselves, forming domains. This is absolutely correct. There are domains which are created in ferromagnetic material. That is the reason behind their excessive amount of magnetic properties. At high enough temperature, the domain structure of ferromagnetic material disintegrate. Thus, magnetization will disappear at high enough temperature, known as Curie temperature. Absolutely correct. At this particular temperature, the materials, they disintegrate, and basic point is that ferromagnetic material convert to paramagnetic material. So, yes, option number 1 is the right answer. That R is not the correct explanation, absolutely correct. This is not the correct explanation for this, but this is right. So this is right, but this is not the correct explanation of assertion, right? So option number 1 is correct, that R is not the correct explanation of A. I hope this is making sense. Now, in a perfectly inelastic collision, there are two spheres made of the same material with masses 15 kg and 25 kg, okay? Moving in opposite direction with speeds of 10 meter per second, 30 meter per second respectively, they strike each other and stick together. Obviously, this is a perfect inelastic collision, so they are going to stick. The rise in temperature if all the heat produced during the collision retained by these spheres is. So, simple point over here is the delta K over here, which is going to be the initial kinetic energy minus the final kinetic energy, right? So the initial kinetic energy, which you can calculate, mass into velocity square with a half, minus the final, and final how you are going to calculate? By conservation of linear momentum, right? So V final will be simply equal to, they are moving in opposite direction. So m1 v1 minus m2 v2, that will give you the final mass into velocity. Okay, so you'll be able to calculate the final the final kinetic energy over here. Okay, perfect, sir. Now when the final kinetic energy will be placed and you will be able to find out the value of delta K, then this energy is actually going to be used up in increasing the heat energy. So this delta K will be placed as ms into delta T, where m is going to be the mass, which is 15 and 25, because they both are sticking to each other. Specific heat capacity of sphere material is given 31 calorie per kg, and 1 calorie is also given, it is 4.2 joules. So you obviously need the answer in joules, right? Calorie is not the SI unit, you will have to play around in joules. So keep 4.2 also over here. And mass is given, S is given, you need to calculate delta T from that. So based on this approach, option number 2 will be the answer, 1.44. Okay. Moving ahead, there are two small balls with masses m and 2m. They are attached to both ends of a rigid rod of length d and negligible mass. If angular momentum of the system is L about an axis A passing through its center of mass and perpendicular to the rod, then angular velocity of the system about A is. So what is going to be the angular velocity? See, the point is, if there are two masses m and 2m, you can obviously locate their center of mass, right? You already know that this distance will be equal to 2m upon 2m plus 3m into the total distance, which is r. And similarly, this distance will depend upon this, correct? Now, simple point, actually this distance, center of mass will be closer to this, not over here. Now, once you have decoded the R1 and R2, you can very easily find out the moment of inertia about this axis, right? The moment of inertia will be, the moment of inertia for this, I1 plus I2. The moment of inertia of this into omega will give you the total angular momentum, which is L. So basically you just need to divide moment of inertia and omega will be calculated. The answer over here is going to be option number 1, 3/2 L upon md square. Clear? You have a 20-meter long uniform copper wire held horizontally is allowed to fall under gravity through uniform horizontal magnetic field of 0.5 Gauss perpendicular to the length of the wire. Okay. The induced EMF across the wire when it travels a vertical distance of 200 meter is. So induced EMF will be V cross B dot L, right? Now when it is moving down a distance of 200 meter, so obviously what is going to be the velocity? That will be equal to root 2 GH. So you can calculate the value of velocity, magnetic field is already given, length is already given, you can very easily find out the answer over here, which is going to be option number 3. So it's simple, it's not at all difficult. Moving ahead, a thin prism with angle 5 degree of refractive index 1.72 is combined with another prism of refractive index 1.9 to produce dispersion without deviation. The angle of second prism is, so see, you want dispersion but you don't need deviation. That means the deviation of the first prism, which will be nu minus 1 into A, that should cancel the deviation of the second prism, right? So it should be equal to mu2 minus 1 into A2, correct? So if you just equate both of them, nu1 is given 1.72, A is also given, nu2 is given 1.9, you need to find out A2. If you will solve it, you will get the answer as option number 3, that is 4 degree. Simple problem, okay? Then 2 point charges 2q and q are placed at vertex A and center of phase CDEF of the cube as shown in the figure. The electric flux passing through the cube will be, what is going to be the electric flux passing through the cube? See, come on, whenever you have a charge at the corner, the flux is 1/8 times the total flux due to the cube, or basically 1/8 times q by epsilon naught. So it will be 2q by 8 epsilon naught, that will be q by 4 epsilon naught. Due to this, it is turning out to be 2q upon 8 epsilon naught. Due to this, if I keep another parallel charge, the sharing is going to be q by 2 epsilon naught, the charge is q only. If you solve it, you will get the answer as 3/4 q by epsilon naught, right? So it is turning out to be q by 4 epsilon naught plus q by 2 epsilon naught, multiply 2 and 2, you will get the same answer. Simple problem, I hope there is no trouble. In a screw gauge, the zero of the circular scale lies 3 divisions above the horizontal pitch line when their metallic studs are brought in contact. That means this is, they are talking about a zero error over here, right? So 3 divisions, that means every division, the least count is given 0.01 meter. So there is a zero error over here, okay? Using the instrument, thickness of a sheet is measured if pitch scale reading is 1 mm, okay, and the circular scale reading is 51, okay, then the correct thickness of the sheet is, right. So basically, see, the simple point over here is whatever is your main scale reading plus n into the least count, okay, whatever is your main scale reading, right, the final reading over here is going to be whatever is your main scale reading, right, on the wherever that screw is, plus n is basically the point where the reference line touches, into the least count over here, and you will have to subtract the zero error out of it, right. So simple formula, you can very easily find out whatever is the option. The correct answer is going to be option number 4. Cool. Now, moment of inertia of a square loop made of 4 uniform solid cylinders, each having radius capital R and length L, about an axis passing through the midpoint of opposite sides. So moment of inertia of a square loop made of 4 uniform cylinders, okay. So it's a square loop made of 4 uniform solid cylinders, each having radius R and length L, about an axis passing through the midpoint of the opposite sides of a square loop made of 4 uniform solid cylinders and length L, about an axis passing through the midpoint of, okay, okay. I think they are talking about this kind of a structure, right? This is one thing, then there is this thing, then there is this thing, okay, and then there is this thing over here, okay. This is the kind of a structure. Now, this is a square loop being formed, if you can understand. Their axis is forming a square loop with cylinders. Now they want the moment of inertia about this axis over here. Clear? So first you will have to find out the moment of inertia about this axis, which is just like uniform solid cylinder. So you can just apply parallel axis theorem to find out for this and for this. And for these two, you will have to find out first along axis and then along this, in which the radius will also be included. So about this, these two will be different, correct? And in these two, the top and the bottom one, you need to find out about this axis, right? So for the top and the bottom one, you can apply parallel axis theorem. For this one, you will have to apply the first, which is ml square by 12, and then along the center over here, okay? So correct answer for this is going to be option number 2, right? ml square by 2 for this, for this, for this, for this, and then for these two, you will have to add differently, okay? So this is how the scenario is going to be, correct? Take the mass of the entire loop as m. Okay, so entire loop also, you will have to distribute the mass equally, correct? So masses also will be taken into picture. Based on that only you will get this answer. Now there is a small bob of mass small m is attached to a massless rigid rod of length 1 meter pivoted at point P, okay, okay. And kept at an angle 60 degree with vertical as shown in figure. A distance of 1 meter below point P over here, an identical bob B is kept at rest on a smooth horizontal surface that extends to a circular track of radius r as shown in figure. If bob B just manages to complete the circular path of radius r up to a point Q, that means it is able to reach this point Q from here to here, right? After being hit elastically by bob A, then radius r is going to be. So the point is, see, the scenario is given, this is 60 degree, this is 1 meter length. So you can very easily find out this length. This is going to be 1 cos 60, and cos 60 is 1 by 2. That means this length is 1 minus 1 by 2, that is 1 by 2. So when the ball goes over here, it will have a velocity equal to root 2 gh, where height h will be 1 by 2. Now this velocity will be imparted completely to this small m bob. Reason being, it's an elastic collision. So the same velocity root 2 gh. With this velocity, the object will reach. Now, what is the condition? The condition over here is that the velocity at the bottommost point should be greater than root 5 gh. So root 2 gh should be greater than root 5 gr. So based on that, you will be able to find out the answer. Okay. Answer number 1 is coming, right? So the radius can be calculated easily. Clear? Moving ahead, now you have the scenario, the case over here. So in this case, we need to match the column, right? So obviously integration of B dot dl is mu naught. This is Ampere circuital law. And I can see a parallel relation over here. B dot dl equals to mu naught I plus epsilon naught d phi E by dt. This is Ampere Maxwell law. So B is standing for 3 and D is standing for 1. Right. Option number 1 is the right answer. Okay. So 1 is going to be the right answer over here. Now, next case, the following diagram shows a Zener diode as a voltage regulator. The Zener diode is rated at Vz is equal to 5 volt. Okay. And the desired current is 5 milliampere. The unregulated voltage source can supply up to 25 volt. Perfect. Considering the Zener diode can withstand 4 times the load current, the value of resistance Rs will be equal to. Perfect, no problem. So simple point over here, this is under a reverse biasing condition, right? The Zener diode is rated as 5 volts, so it will maintain a 5 volt potential across it, right? And the desired current in the load, so this is the load, the desired current in the load is 5 ampere, 5 milliampere. Perfect. The unregulated voltage source can supply up to 25 volt. So it can supply up to 25 volt. Considering the Zener diode can withstand 4 times of the load current, the value of resistor Rs will be equal to. Now see, this will make sure that the potential across this is 5 volt, right? Perfect. So if this is 25, out of which 5 volt is gone over here, so remaining is 20, right? And based on that, here the potential difference across this is turning out to be 5 milliampere. That means the RL value will be equal to 5 volt upon the current, which will stand to around 1000 ohm, if I am not wrong, correct? Then this is 1000 ohm, perfect. And then you have the value of the potential difference across this, and moreover it is also given the Zener diode can withhold 4 times the load current. So the current through this is basically going to how much? 4 times of this, that is 20 milliampere. If I am taking it the maximum, then the load current also is going to be maximum. So whatever is the current which is going over here, some portion is going over here and the other portion is going over here. So the total current which is passing through this is 25 milliampere. Correct? Now 25 milliampere, based on that, you can very easily find out the value of Rs. The potential difference is clear and the other portion is also clear, right? So option number 1 will match the scenario. Clear? I hope this is making sense. Now, talking about the next thing over here, the stress strain plot for material A, B, C and D is shown in the figure. Which material has the largest Young's modulus? Now, it's a simple thing. Stress is to strain will give you the value of Y, right? So basically the delta in stress is to delta in strain is going to be the slope, which will talk about the Y, and slope can be represented as tan of theta. So whichever has maximum value of theta, which is obviously A, will have the maximum value of Young's modulus. Okay. Okay. Now there is an issue. The issue is stress is plotted along y-axis and strain is plotted along x-axis over here. So in this case, it's just the reverse. Delta of strain is to the delta of stress will basically talk about tan theta, right, and will give you the value of 1 upon y. So whichever has the maximum value of y, the maximum value of theta will have maximum value of tan theta, will have the least value of Vs. So it will have the least value and it will have the maximum value. So C is the right answer, option number 1. Okay. So please be attentive what is plotted along y and x. Now the object is projected with kinetic energy K from a point A at an angle 60 degree with horizontal. The ratio of differences in kinetic energy at point B and C to that at point A in the absence of air friction. Okay, so the ratio of the difference in kinetic energies at point B and C to that at point A. So see, here the kinetic energy is simply going to be due to the horizontal velocity, which will be V cos 60. Correct. So obviously V cos 60 is V by 2. Earlier was V, here it is V by 2, and here also the velocity will be V. So kinetic energy over here is going to be 1 by 4, half of m into V square by 4. And here it is going to be half of mv square. So difference is 3 by 4. So ratio with this is obviously going to be option number 3, which is 3:4. Simple problem. Simple pendulum of straight length 30 centimeter performs 20 oscillations in 10 seconds. The length of the string required for the pendulum to perform 40 oscillations in the same time duration is. So now 20 oscillations is standing to 10 seconds, right? So one oscillation will stand equal to 10 by 20, that is 1 by 2 second, correct? Now you want that 40 oscillations should also be done in 10 seconds. So now for one oscillation the time period is going to be 10 by 40, that means 1 by 4 second. So you want the time to reduce. You want the time to reduce, the time period to reduce. So how much length should also reduce? So based on that time period, t equals to 2 pi under root of L by G. So you can very easily find out the value by simple ratio. It's going to be option number 3. From 30 centimeter, you need to reduce the length to 7.5 centimeter. Consider light traveling from a medium A to medium B separated by a plane interface. If the light undergoes total internal reflection during its travel from medium A to B, and the speed of light in medium A and B are 2.4 into 10 raised to the power 8 meter per second and 27 into 10 raised to the power 8 meter per second respectively, then the value of critical angle over here is going to be. So critical angle, the sine of theta will be basically equal to mu of the rarer medium to mu of the denser medium. Okay. Now nu of the rarer to nu of the denser means velocity in the denser medium to velocity in the rarer medium. Correct? Because the sine theta should always be less than 1. So velocity in the denser medium is, sir, in the denser medium obviously the velocity is going to be smaller. Correct? So I think there should be a point also over here, because 27 is breaching speed of light. So this is the velocity in denser medium, this is the velocity in rarer medium. Through that, by just dividing, you will be able to find out the value of sine theta. So option number 4, by a plane interface, if the light undergoes total internal reflection during its travel from medium A to B, right, and the speed of light in medium A and B, right, so denser to rarer, perfect. So this is denser. So velocity in denser is to velocity in rarer. So sine theta, I think the value will match this. Sine theta over here will be equal to 2.4 upon 2.7, 24 upon 27. This will be 8 is to 9. So theta is turning out to be sine inverse 8 is to 9, right? Obviously sine inverse 9 by 8 is not possible. So I think based on this, you will now have to find out the value of tan theta also, because this can also be probable answer, right? So if 8 and 9 are perpendicular and hypotenuse, right? So the value of base is going to be how much? Base will be 81 minus 64 whole under root. That amounts to 17. Yes, so 8 by root 17. Option number 4 is correct. This is not matching. This is not matching, right? In hydrogen atom spectrum, R is Rydberg's constant, the maximum wavelength of radiation of Lyman series. Now see, I think you already know this thing. The Balmer series lies in the visible range. This is absolutely correct. This thing is absolutely correct. B1 is right. So B is correct in all of them, right? Now minimum wavelength of radiation of Pascal is 9 by R, the minimum wavelength of Lyman. See, the minimum wavelength scenario arises wherever the energy gapping is maximum. Okay? So whenever in Lyman series, obviously if an electron is jumping from infinite to n equal to 1, you will have the minimum wavelength, right? And the maximum wavelength will arise when it is jumping from n equal to 2 to n equal to 1. I hope you can just find out the value of energy gapping, and based on that, option number A, B and C are going to be correct. This is right. 4 upon 3R, and minimum wavelength of radiation in Pascal series is 9 by R. Okay. So I hope this is making sense. The de Broglie wavelength of an oxygen molecule at 27 degrees centigrade is x into 10 raised to the power minus 22 meter. The value of x is, what is going to be the value of x? So the de Broglie wavelength of an oxygen molecule at 27 degrees centigrade, see, the de Broglie wavelength is this, right? The value of x is going to be, now here the de Broglie wavelength will be related based on its thermal energy. Okay, so it's inversely related to obviously the mass of the oxygen molecule as well as the temperature, correct? So you need to just use the formula. It will be option number 3, correct? So 2mk into T, this will give you the value h upon under root of the linear momentum, which will be equal to the thermal energy portion over there, right? Then the equation of the electric field in an electromagnetic wave propagating through free space is given by E is equal to under root of 377 sine of 6.27 into 10 raised to the power 3t minus 2.09 into 10 raised to the power minus 5x Newton per coulomb. The average power of the electromagnetic wave is 1 by alpha watt per meter square. I think this is a simple problem, formula based problem. The alpha will be equal to 2, right? Whatever is the average power. It's a simple problem. In two separate Young's double-slit experimental setups and two monochromatic light sources of different wavelength are used to get fringes of equal width. The ratio of the slits separation and that of wavelength of light used are 2:1 and 1:2. Okay. The corresponding ratio of distance between the slits and respective screens is. Now see what they are saying, there are two YDAC setups and the monochromatic light sources of different wavelength are there. Wavelength is different. Used to get fringes of equal width. So fringe width is same. So lambda capital D upon small d is same for both of them, wherein lambda 1 and lambda 2 are different. Okay. The ratio of the slits separation and that of wavelength of light used are this, the corresponding ratio. So this is also different and this is also different, correct? So they have given the ratio of lambda 1 is to lambda 2, and they have also given the ratio of slit separation, which is they have given the ratio of d1 is to d2 also, and they are asking the ratio of capital D1 is to capital D2. I think you can very easily find out the answer. It's going to be 4. Perfect. The space between the plates of a parallel plate capacitor of capacitance C without any dielectric is now filled with 3 dielectric slabs of dielectric constant K1 is equal to 2, K2 equals to 3 and K3 equals to 5. If new capacitance is N by 3C, then the value of N is going to be. So see, first of all, capacitance C should be equal to A epsilon naught by D. Okay. Now the next portion is, see the plates are like this, right? So you will have to break this K1 into 2 parts, right? So first you will have to find out the equivalent of these two in series combination and the equivalent of these two in series combination, and then both of them in parallel. Okay, so in series combination, I think you already know it's A epsilon naught. The area is going to be A by 2 epsilon naught D by 2 upon the value of K1 plus D by 2 whole divided by the value K2, correct? Then they are both going to be in parallel. So in parallel you can directly add them, correct? Then it is going to be A by 2 epsilon naught whole divided by again D by 2 upon K1 and D by 2 upon the value K3, correct? So this you will have to relate with this. Answer is going to be somewhat N by 3 times C. So you can find out the value of N. It is going to be 8. The answer is going to be 8. Using a variable frequency AC voltage source, the maximum current measured in the given LCR circuit is 50 milliampere. Maximum current measured in the given LCR circuit. That means they are talking about I naught. For V equals to 5 sine 100t. The value of L and R are shown in the figure. The capacitance of the capacitor used is, okay. So when you get the maximum value of current, you get the maximum value of current obviously at resonance, right? Wherein XL is equal to XC. So omega is given, frequency is given. I think you can very easily find out the value of capacitance. It's not a tough question. It's very easy. Okay. Perfect. Perfect. Right. So it is going to turn out to be 50. The value of capacitance will turn out to be 50 over here. A simple pendulum, this is the last problem, a simple pendulum of mass 10 gram and a metallic wire of length 10 centimeter is suspended vertically in a uniform magnetic field of 2 Tesla. The magnetic field direction is perpendicular to the plane of oscillation of the pendulum. If the pendulum is released from an angle of 60 degree with vertical, then maximum induced EMF between the point of suspension and point of oscillation. And a metallic wire of length 10 centimeters suspended vertically in a uniform magnetic field of 2 Tesla. The magnetic field direction is perpendicular to the plane of oscillation of the pendulum. Okay, so this is the case. This is the pendulum, and magnetic field line is in the cross direction. Okay. If the pendulum released at an angle 60 degree with vertical, then maximum induced EMF between the point of suspension and the point of oscillation is going to be. Now see, there is a wire, right? And due to the wire, there is going to be an induced EMF in the wire. Okay. So they are asking the maximum induced EMF between the point of suspension and the point of oscillation. Basically, from this point till this point over here. Because here the object will have maximum velocity. So here this will have the maximum velocity. So based on this maximum velocity, the induced EMF will be how much? So we will have to find out the value of maximum velocity when it goes down by 60 degree. Initially it is given, it is aligned at 60 degree with the vertical, right? So when it goes down, you will have to find out this height. Then whatever is going to be the value of velocity, that will be the value of velocity of this metallic wire also, right? And metallic wire mass is not given, so you can ignore it. You just need to consider the mass of the pendulum. So the velocity V cross B into L will give you the value of EMF, whose value will be equal to 100 millivolt. Okay. So I hope you have understood all these questions. Overall, the paper was not that difficult. It was more or less in the moderate range only, right? So that's going to be all for this paper. I hope you have understood it. Thank you so much. Bye-bye and take care.